Okay. So this is the confidence limit level. So we are saying the function of this table is to get your T from here, okay? The T, the statistical value on that confidence limit calculation. So you get your T from here. And we said the T, you can get it by considering the fact that T is almost equal to the degree of freedom, which is V. So we said V is obtained as n minus 1. So where is the V on this table? So the V values are these values going down here. Okay? All these 1, 2, 3, 4, all these are the V values. Okay? So all these are the V what? Are the V values. 1, 2, 3, 4 going down there. So if they ask you, for example, the example is find the degree or the T value when n is equal to 5. So when n is equal to 5, your V must be equal to n minus 1. So it will be 5 minus 1. So your V is equal to what? 4. So we are trying to find T when n is equal to 5 at what confidence level. So you can have a confidence level at 90 degrees or confidence level of 95, 99, and 99.9. It is very poor. So we found out that our V, when n is equal to 5, our V is 4. So at 95% level. So first of all, we know to say these are the V values here. So when V is 4, you are here. Okay, that's your V. So your V is 4. At 95, so you go in the same row so that you reach 95. So you come up to here. So meaning that your T is this value. So when V is 4, your T is that value. Therefore, when n is 5, the T value is this value here. So that's how you get your T from the confidence limit level. Okay? Are you okay with how you obtain the confidence limit level?
Yes.
It is okay. All right. So now let's proceed, and so this is how you use this confidence level limit. You just use it to get your T. So if your n is 3, then you find that your V will be what? 2. So again, you check which percentage are you working with. Is it at 95 or 99? Then you get your T from there. That's the T you come and replace in the equation. All right, so let me share another board. Let's look at F-tests. Let's look at F-tests now. So let's look at F-tests. Okay. So the F-tests, This one is just used to evaluate the two methods that you are dealing with, okay? So F-tests, in summary, we can say it evaluates the differences between the two methods. So the idea you are trying to check here is that if you are working with one experiment, then you want to use two different methods. You need to find out if they are workable enough. To confirm that fact, you need to check if you have got differences in terms of variances between the two methods, okay? So, how do we get the difference, okay? So you should have F calculated. So to get F test, so to get F, which we are calling as F calculated. So F calculated, remember that you have two methods, meaning each method will have its own what? Variance. So you are going to say the variance for method 2, okay, over the variance for method 1. So what you put on top, the variance you put on top is the variance which is greater than the second variance. So you should always take note that S or variance 1 or the one on top must always be greater than the variance you are putting on the bottom. So that's the principle when you're calculating for F. The one you put on top must be greater than the one you put on the bottom. Now, what are we trying to calculate here? So, you are going to have F calculated, the one that you manually calculate, and you're also going to have F tabulated. So F tabulated is the one that you get from the F test table. Okay, so F tabulated, you get it from the F test what? Table. I'll show you how. So how do you check if there is a variance in, there's a difference in the two methods, okay? So if F calculated is greater than F tabulated, meaning there is a significant difference between the two methods. So if F calculated you have found is less than the F tabulated, meaning the F you get from the table, the F tabulated, meaning there is no significant difference. There is no significant difference between the two methods. Okay, so that's the principle. You just have to check. Then if you find that F calculated is greater than F tabulated, then you'll be able to conclude that there is a significant difference between the two methods. So how do we get F calculated? F tabulated rather. So again, from the same table, observe what we have on the bottom there. It's the values of F at 95% confidence level. So this is where you get your F tabulated. So pay attention. Observe that, for example, again, you need to have values. So V is always, to get V is always n minus 1. That's the principle. So for example, if you have two methods, method 1, so I'll call it M1, and this is M2, okay? M1 and M2, then M1 has the n value of 5, and M2 has the n value of 4. Let's find the F tabulated for this. So when n is 5, we know to say V is what? 4. And when n is V1, and when V is n is 4, so for V2, n is equal to 3. Okay? N is equal to 3. So now, if you have observed very well, you have the V1 on top. So the V1 is acting as the row, and the V2 is acting as the column. So let's check. V1 is 4, so meaning you shunter here V1 of 4 and V2 of 3. So you'll be at this point here. Then you check where the two are meeting. So this is going up to here, and 4 is also coming here. So where these are meeting, this will be your F calculated, meaning that your F tabulated rather, meaning that your F tabulated is equal to 9.112. You get it from the table. Then the F calculated is the one that you use the variances of the two. You find the two variances and divide. That becomes your F calculated. Then you compare. Is there a question?
Mr. Kinda, how do you find the S1 and the S2? Is it going to be required of us to calculate, or are we going to be given?
No, you are going to calculate. Meaning you have to go through the procedure of calculation of standard deviation so that you find the variances, because those S values are variances. So first thing, you need to calculate the standard deviation, then you find the variances, meaning you find two standard deviation for you to get two variances.
Okay, all right.
Perfect. So if we proceed and look at the last one, which is the Q tests. So I've looked at F tests, we've looked at confidence level. So we can now look at the F tests or the Q tests. Okay. So the Q tests is basically used to
They should just give up. I'm telling you, they should just give up. I've gone back to academic research. But after I've written everything we did.
So Q-test. So Q-test is the last one. So basically Q-test is used to calculate, or rather it is used to discard some variables. Some variables, we are not interested in, that looks to be outliers. So Q-test sometimes is also known as rejection tests. Rejection tests. So if you have a lot of people, you can use rejection tests to discard some people. So in this case, we are using variables. So just a brief, this is used to describe, or rather determines, the outlier. So an outlier is that variable that looks suspicious if it can be retained, if it can be retained, meaning you don't have to discard it or discarded. So it is the Q-test that will help us to determine whether to discard that variable we suspect to be outside of your measurements, or to retain it, meaning not to discard it. So we use Q-tests to do so, okay? So now, how do we find Q? Q is one of the best. Q is basically equal to A over W, A over W, okay? Or this can be written as modulus of A, because whatever you get inside, whether positive or negative, you have to make it positive over W. So where this modulus can be seen to be the suspect value minus the neighbor, okay? The suspect value minus its neighbor. Its neighbor is the nearest value. So that's how you get your A. So you have to put it in a modulus to get your A. And then W is basically the range. So W is the range of variables. So this is the range. So this one is known as Q calculated. The one that we have just calculated using this formula. So that one is the Q calculated, meaning that for you to be able to know whether the suspect value must be discarded or retained, you also need to have the Q tabulated, okay? You should also get your Q tabulated. So if Q are calculated, the one you have found is greater than the Q which is tabulated, then that suspect value must be discarded. So then suspect your suspect value. Okay, thank you so much for that. Yeah, so I was saying, if at all you have the T, your V to be, for example, if your V is given to be 6, at 95%, you'll be able to find that your Q at 95% will be 0.625. So you get this and compare to the Q that you calculate from that side. After doing that, if the Q calculated is greater than this value, then your suspect must be discarded. But if the Q calculated from that side is less than this value, then you need to retain that value. All right, so that's pretty much of what is actually happening on statistical part. So, well, we have done much of the theory. What is remaining is now calculations. So let me show you one question that you can do. One question that you can do. And of course, you'll be enjoying this work. It is one of those that is interesting. So I don't know if you have a question. Okay.
My question, Mr. Kun.
Well, Olivia, can you, I'm unable to get you. That's your question. Olivia, what's your question? Hello?
Okay. My question was before you unmuted your mic. I don't know if you gave an example of n, because on the table I saw an arrow going on 6. So my question was, did you choose n as 7?
Yes, I just
Or
said,
maybe,
let's say n is 7, then which means our v is 6.
okay.
Yes, yes, I just chose 7 to be our n. Any other question? Do you have a question? Or should you look at an example? Okay, let's look at this part. Okay, I'm going to look at the last part. These questions from here. I don't know if you are able to see. So we'll start with C. So the last question for C is okay, we are ending the meeting. Let me just look at the last part. This has been one of the classes you hate most. Okay, so we have this question here. The following masses were recorded for 12 different Zambian 1 kwacha coins, all given in grams. So we have this week. So this is like one thing here, starting from 5.683 to 5.632. Report the mean. So you are going to get the mean, the median, the range, standard deviation, and variance of this. That's just for C. Then after that, you are going to give within what range are you 95% confident that the values lies. So the idea is for this last part, you are now going to use the confidence limit. Okay, so find the confidence limit at 95%. So I showed you how to get the confidence limit at 95%. So that's how you get that question C. Question number B. Okay, so for B, For B now, you are trying to check if, for B, you are trying to check if, so they are saying the following sets of determination on separate allocates of pooled blood serum were reported 103, 106, and 107 in 114 milliequivalent per liter. One value appears to be a suspect. Should the suspect be retained or discarded at 95% level? So again, this is one and the same. All you have to do is you would be dealing with the Q tests. So find the outlier. So in this case, the suspect is basically 114. It appears to be far away from these other values. So that one will be the suspect. Then your immediate neighbor is 106 and 107, and find the range. Then from there, you can go and find the tabulated from the table and calculate for, and comment whether the values must be retained or discarded at 95 degrees or 95% confidence level. Are we getting the scenario? Hello? All right. Then the last one is basically just A. These are the two methods that you are working with. So for this one, they want you to confirm F tests. Okay, so you do F tests for those, meaning you are going to find the variances of the two methods, your methods, and also following who method. So find the variances of the two so that you can have the F calculated. After finding the F calculated, you can now find the F tabulated and compare the two. If F calculated is greater than F tabulated, you compare that there's a significant difference between the two methods. If not, there's no significant difference. All right, so now we can end here. We can end here, meaning you are all okay. If you have a question, please unmute your mic and ask a question. If not, then let's end here. I'll be able to, I'll be waiting for your work. Once you do the work, you can send to my inbox. I'll be able to check it. If there is no question, or if you have a question, please ask. Okay, so let's end here. I'll share the videos for those who have not attended.